Good morning, everyone. It's a pleasure to be here today, and I'm excited to talk to you about the benefits of work, energy and kinetic energy. Together, we'll be looking at the connections between the three and how they can help us understand the world around us. Let's dive in. Work is an essential scientific concept. When a force acts on an object and causes it to move in the direction of that force, it is considered work. Work is calculated by multiplying the magnitude of the force, F, with the displacement, S, and is given the symbol W with the equation W equals Fxs. The unit of work is the joule, J, which is equivalent to 1 Newton-meter, Nm. For example, if a force of 5 N moves an object 2 meters in the direction of the force, then the work done on the object is 10 Newton-meters or 10 J. The force and displacement of the work we do can be either in the same direction, which would be considered positive, or in opposite directions, which would be considered negative. Work is also zero if there is no displacement, or if the force is perpendicular to the displacement. For instance, when we lift an object, the object is displaced in the direction of the force and the work is considered positive. However, the force of gravity also inherently acts in the opposite direction, so the work done by gravity is negative. To provide an example, a porter lifting a 15 kg luggage 1.5 meters above the ground would be doing 225 joules of work. Energy is the capacity of an object to do work, and is measured in joules. Various forms of energy exist, including heat energy, light energy, electrical energy, chemical energy, mechanical energy, and kinetic energy, which is the energy possessed by moving objects. Burning biomass, like wood, charcoal, and dung for activities is a prevalent practice in developing countries, and a major contributor to indoor air pollution, which can be a serious health problem. Kinetic energy, an essential concept of physics, is the energy possessed by an object. It is calculated by multiplying the object's mass by its velocity squared. For instance, an object of mass 15 kg moving at 4 meters per second has a kinetic energy of 120 joules. This energy is put in the equation E equals mv squared, with m being the mass and v the velocity. Applying these values, E equals 15 kg, 4 meters per second, squared equals 120 J. Potential energy is the energy of an object because of its position or shape. Stretched rubber bands, compressed springs, and objects lifted to a certain height are all examples of potential energy. When these objects are stretched, wound, or lifted, energy is transferred to them and stored as potential energy. When the stored energy is released, the potential energy converts into kinetic energy, which is seen in motion. Grasping the concept of potential energy is vital in physics as it helps to explain and anticipate the motion of many physical objects. Energy transformation is an essential notion expressed by the law of conservation of energy. Energy cannot be created nor annihilated and will always be converted to another form. For instance, when an object is dropped from a height, its potential energy is greater at first, but as it falls, it converts potential energy into kinetic energy. The potential energy lessens and the kinetic energy grows until the object touches the ground, when the kinetic energy is the highest and the potential energy is the lowest. Nevertheless, the total mechanical energy, being the sum of potential energy and kinetic energy, will always remain the same. Power is an essential element of our lives, impacting many aspects of our day-to-day activities. Work, energy and kinetic energy are all connected in the process of accomplishing work. Power is the speed at which work is done and is measured in watts, with 1 watt being equivalent to 1 joule per second. A kilowatt is 1000 watts or 1000 joules per second. By understanding power, we can identify ways to make work more effective and ensure our energy is used to the greatest extent possible. Kilowatt-hour is the commercial unit of power. It is the amount of energy used in 1 hour at the rate of 1 kilowatt, which is equal to 1000 joules per second. In numerical form, it is 3.6 x 10 to the power of 6 joules of energy. This unit is commonly used to measure the electrical energy consumed in homes and industries, and is usually expressed in units, with 1 unit equaling 1 kilowatt-hour. Thank you.